Hey everyone, thanks for joining. We're going to be covering a lot of really exciting things, especially with a lot of the core team members from the engineering side of Ava Labs. And I think to start off, the best way to go around this would be to do a quick round of intros. I'll quickly start. On my end, I'm the VP of Marketing at Ava Labs, currently focused on making sure that Avalanche is going far and wide all across the globe. And maybe Connor, if you want to go next.
Sure. So I'm a software engineer at Ava Labs. I do a lot of work with smart contracts and Solidity and building on the Avalanche C chain. And yeah, my claim to fame at work here so far is that I've done a lot of work on the Penguin DEX.
Awesome. Thanks, Connor. Steven, if you want to go next.
Yeah, hey guys. So I'm Steven. I've been working primarily on the Avalanche Go repo, so core platform stuff for the past 2+ years. So that's my focus, and that's kind of where I work.
And I think, Steven, maybe if you want to touch quickly on some of the consensus work you were doing a few years back.
We can jump into that. So basically, when the Avalanche paper first dropped, I was very excited on that, and so I ended up meeting up with Goon and ended up doing a lot of work with him on fleshing out kind of the protocol and just kind of like tidying things up and wrapping things up. Um, so. Um, so that's kind of the first time that I really worked on like implementing consensus protocols. But in the past, I had kind of done some research into some of the classics like PBFT and some going really far back like Benor, Braca, things like that. So I don't know if that answers your question, but
Yeah, basically saying anything protocol / consensus level, just shoot them at Steven in terms of questions there. But yeah, thanks, Steven. Next up, Aaron, if you want to do a quick intro.
Sure. Yep. I'm a software engineer as well with Ava Labs. I've been working with Ava Labs for the past 2 years or so. I've been working on Avalanche Go with Steven for a long time, and as of about 6 months ago, I've been working on Core ETH as well. So that's the VM implementation for the contract chain or C chain. Yeah.
Awesome. Thanks, Aaron. And lastly, Gabriel.
Thank you very much. Hey, everybody. This is Gabriel Cardona. I have been at Ava Labs for right under 1 year. I joined in May of last year, and I work on Avalanche JS, and I also help with developer services. So you might see me out there at hackathons or giving presentations. And that's it.
Awesome. So I think everyone's gotten a quick overview of what every person is especially good at, but also not to limit the fact that most of us are most likely working on a variety of different things. So for today's discussion, want to cover the upcoming platform upgrade as much as possible. So as most of you may or may not know, it's called Apricot, and that's kind of the main focus of the engineering team. And so we'll push through a lot of the main components of Apricot and have a lot of these guys showcase what they've been working on and also what it means for you, especially for those who aren't necessarily developers. I think a lot of this can be very useful to really decipher kind of the technical elements of the various components that are either currently being rolled out as we speak or something that's coming down in the pipeline in the future. And so maybe what we can talk about first to kick things off is just kind of the general approach of Apricot. Not sure who on the engineering side wants to take that, but we can start with a general overview and then maybe zoom in on some of the specifics.
yeah, maybe I can talk a little bit about it. So when we first started thinking about Apricot, it was kind of this mega upgrade that included like a bunch of different things. So it included, we wanted to introduce dynamic fees. We wanted to introduce fast syncing. We wanted to, just do some improvements on the C chain, add governance, things like that. And essentially, as we were building Apricot out, we wanted to keep kind of adding more and more features to it. And it just kind of turned into this like mega upgrade. And so what we decided to do instead is to kind of slice it up into a bunch of different phases. And so upcoming on Wednesday, I know we have already, I think 94% of the network is upgraded for the first phase of the Apricot upgrade, which is modifying the C chain a little bit to reduce some fees and also remove gas refunds, things like that. So that's kind of a brief overview of. I touched really quickly on a couple of things that we were hoping to introduce in Apricot, and kind of why we decided to split it up was just because it kind of started getting too big for us to kind of like just push out in one big step. So we decided to break it up. But yeah.
And maybe Steven, do you want to also kind of cover some of or I guess the immediate phase one that we're pushing towards?
Yeah, so I did briefly just touch on it, but the phase one that we're pushing towards for Wednesday is will reduce the C chain fees. So right now, as many of you may know, the gas fee is a hard-coded minimum. So the first phase of that is just kind of readjusting it a little bit because the price did some unexpected things in the past, few months since we launched, and so we're trying to adjust that a little bit to, let developers continue to work on us while at the same time introducing an additional change that we wanted to make, which is removing the gas refunds, which have been an EIP on Ethereum for a long time, but hadn't been introduced for one reason or another for them. But
and could you maybe expand a little bit on the gas refund side, maybe more for the non-technical users?
Yeah, so in Ethereum, when someone issues a transaction, there is a computational complexity when they execute the transaction. And so, some transactions might do a lot of work and other ones might be very fast. And so to account for that, they have this notion of gas. So when a transaction performs an operation like an add, that takes some certain amount of gas. When it performs a store, it performs another type of, it reduces more gas. So storage operations actually bloat the on-chain state, so they're very expensive. And when Ethereum was first launched, they wanted to suggest for people to remove unused state. And so they introduced a refund mechanism. So if you delete state, then you get money back, which is a great idea off the at the surface. The issue with that, though, is that it introduces a gas mechanism that can be gamed. And so the most famous example of that is gas token. So essentially, people can buy gas token, which bloats the on-chain state, which is actually the exact opposite of what the intention of the refund was supposed to do. So essentially, this mechanism didn't really work out exactly how it was intended, and so there have been suggestions in the past to remove it from Ethereum, and essentially we're adopting it as a first phase towards us trying to push towards some on-chain state awareness. Yeah.
Cool. Yeah, that totally makes sense. I guess some things that were originally rolled out may not have panned out the way they intended. So I think the way we're addressing these things is perfectly normal, especially with something as fast-paced as blockchain. So yeah, thanks for that explanation, Steven. I think the first subtopic within Apricot that we are going to cover is epochs. And I know Aaron and Steven, you've both been working on it. Maybe Aaron, you can take a quick overview and some of the main highlights of what epochs means for everybody here.
Sure, I'd be happy to. Yeah, so basically for the X chain, it runs on a DAG, which is a directed acyclic graph, which means that we don't actually have a total ordering of all of the vertices that exist on the DAG. So we instead have what's just a partial ordering, which makes certain types of operations that are very easy to do on a chain, where you have block A is followed by block B, and you have that very clear total ordering saying one block comes after another, a little bit more difficult to do on a DAG. So one of the most clear examples of that is if we want to do a hard fork, then there has to be some clear point at which the new rules go into effect. So for a chain, you can just say at this block, whether that's by some block number or block height or block timestamp, as we do for the C chain, then you can basically just say at this point, we change the rule set from set A to set B. Whereas for the DAG, we need to have some kind of total ordering in order to apply those changes. So epochs allow us to do that, because what we have is every vertex is a part of that DAG, but in addition, we also have epoch, or they're also categorized into epochs, which is a notion of absolute time. So these are going to be broken down into 6-hour phases as of the current implementation. And so what that means is that at the start, we're actually going to have a really long epoch 0, which is everything up until the epochs are phased into Apricot. And then after that, it'll be epoch 1, and 6 hours later, epoch 2, and so on and so on. And so each of these epochs will be part of a total ordering. And so that means that at any new epoch, we can actually apply a different rule set, which kind of allows us to do a hard fork in the first place. So that's actually one of the reasons why epochs were one of the top priorities to get into our very first network upgrade, Apricot. And so in addition to that, it also opens the door to a lot of cool new features that we wanted to include, such as governance, because anything that you govern, you need to change on chain. Obviously, you need to have some point at which to apply those changes. And in addition, another really exciting feature that we have is freezable assets, because obviously this is easier to do on a chain, but on a DAG, we want to have some point at which this asset that we've attempted to freeze can no longer be moved around. And so that's one of the things that by having epochs and by having this total ordering of the DAG, we can actually apply as well. So there's a lot of really cool features that we can build on top of it once we have this. I think probably Stephen is the best person to go into even deeper into detail there.
Stephen, do you want to take the deeper into detail call right there?
I don't know how deep you want to go, but so essentially, Aaron was exactly right. So essentially what epochs does is it provides kind of a lazy total ordering of the DAG. So one of my most, one of the things that I'm most excited about for the X chain with regard to epochs is that once an epoch has been finalized, then you can create things like state summaries, and so we can reduce the sync time massively by summarizing the state at each epoch, and also as an extension of governance, you can add in like dynamic fees and things like that. So the way this is actually done is like I don't know if you want me to. Yeah, Jay, do you want me to go deep? Like, I don't know.
Well, I think that one of the things that you cover, maybe instead of going too deep, but is some of like the implications, perhaps, and why that's important, especially with maybe dynamic fees and anything else that we may be missing here.
Yeah. So essentially, epoching enables us to perform all the optimizations that we've been looking forward to. So, I know one thing that I am irritated by in the current implementation is like the sync time is kind of getting longer and longer as the chain continues to grow, and looking forward towards a fast sync kind of implementation. And so essentially epochs is really the catalyst for all of the future upgrades of the X chain. And so that's really the main motivation behind it. We might have we're certainly going to have some upgrades tied with epochs. The freezable assets was one that was mentioned, but really epochs is the catalyst for everything else on the X chain.
So would you say it's fair to kind of sum it up in one line? It's an optimization and performance play to have epochs within this upcoming rollout?
Yeah, I mean, I would say adding in epochs by itself doesn't really change anything, but it unlocks all the additional optimizations and features that we wanted to build.
Cool. Yeah, that's exactly the clarification that I think everyone needs there. So that's awesome to hear. It seems like it's opening up a lot of doors for plenty of new things, especially as we continue towards further upgrades post Apricot as well. So maybe the next feature that we have that we could talk about are the freezable assets. And Gabriel, maybe you want to touch on this a little bit as to what that means for the entire platform, and then perhaps what it could also enable, kind of similar outlook to epochs as well.
Sure, absolutely. And I'm outside away from my Wi-Fi, so let me know if I break up, and I'll repeat myself. So, as you guys know, Avalanche is a heterogeneous network of many different blockchains and with different validator sets. It's a network of networks. And so we enable this full spectrum of functionality from completely permissionless networks, which is what we're all used to in the traditional crypto kind of world. You can think Bitcoin, you can think Ethereum. And then all the way on the other side of spectrum, we also enable permissioned networks, because our goal is that we want to create the internet of finance. And we know that today in traditional finance, we're talking about thousands of trillions of dollars worth of assets. And not all of it, of course, is permissionless. You can think of Wall Street with brokerages and banks, etc. So there is a huge potential play for regulatory compliance, and that's one of the many benefits that we offer on Avalanche. And so in this context, we are now introducing freezable assets, and this is basically exactly for what the play here is for what I just mentioned, regulatory compliance. So you can think about a couple examples that immediately come to mind. If you're an exchange and there is suspicious activity, you could freeze some potential assets. You can think about, like I just mentioned, brokerages on Wall Street that do asset management. There are absolutely huge funds dealing in trillions and trillions of dollars in individual companies. And there are, of course, many of these companies. So you can think about asset management. You could think about if a secret key was somehow compromised to an operational address, you could, of course, freeze the asset in that particular case. So freezable asset, we of course, that's just a couple ideas that we came up with. We expect that there will be many, many more different ideas that, of course, we did not come up with. But the major play here is that freezable assets are a regulatory compliance play, and they're going to enable traditional funds and exchanges, etc., to be able to freeze assets if something appears malicious and or suspicious.
Awesome. And that seems then, Gabriel, correct me if I'm wrong, but mostly, or if not entirely, a play just for the permissioned, potential permissioned subnets that would be launched.
Yeah, I think so. I think this is permissioned. You know, if you just want to launch a traditional token and it doesn't need to be able to be freezable, of course, we support that today on our X and our C chains. So, you know, that functionality exists. This is just for that entire permissioned spectrum. And, you know, we have multiple plays here. So on our X chain, we have what are called feature extensions. And today we have 3 feature extensions. We have SecP, 256K1 curve on ECDSA key pairs. We also have NFTs, and then we have what are called properties. That's another feature extension. Properties allow you to tie key value pairs to an address. So for example, you could say every single address which holds this asset has to have some type of, you know, a US passport or something like that. And so this enables you to tie tokens to certain US or to certain legal jurisdictions. And then yes, this freezable assets is one more tool in that tool set for people who are looking for regulatory compliance or permissioned networks.
Yeah, that's awesome. I think especially the enterprise side and institutions who are interested in this technology but haven't plunged completely due to kind of the permissionless and public nature of a lot of the major chains probably has slowed their progress down a little bit. But this type of implementation should definitely be a really good conversation topic, but also something that they could be implementing very, very soon. So really excited for that. Great to hear. In addition to freezable assets, I think we have the ARC20s, and maybe we can hear a little bit from Connor as to what that direction looks like.
Sure. Yeah. So this is a really exciting thing for me. So as Gabriel mentioned, we're not just a singular blockchain. We are this network of networks, a network of blockchains, and we have assets that are on each individual chain. But if we want to have this connected network, you know, one of the key features for us is being able to take assets on one chain and bring them over to other chains and have export and import functionality. And so we've had that really from day one. But for our individual chains, these chains need to know what to do with these new different asset types when they come in. And so because our C chain, where all of our smart contracts lives, originated from Ethereum, the original Ethereum virtual machine that we started working from didn't really know about what these new assets could be or what to do with them, just because Ethereum is a singular blockchain and it doesn't have this kind of architecture. So this is one of our first, really big extensions that we've added to the EVM, and I think it's just going to be the start of what's going to be a lot of new features that we're hopefully going to add. But basically, so these Avalanche native tokens are tokens that we're bringing over from the X-chain. They're assets we're bringing over and converting into tokens. And for those of you who are familiar with these, there's something known as the ERC20 standard, which is a common interface that all tokens on Ethereum try to implement so that they can be transferred and you can query balances of them, and they just all behave identically regardless of which token you're using, whether it's Tether or the Chainlink token or any of these different implementations. And so we've borrowed the same standard on Avalanche, and we're basically creating a mechanism where we can transfer these X-chain native assets. We can export them from the X-chain to the C-chain, and then we can convert them into an ERC20 interface so that you can interact with them just like you could through any standard Ethereum style smart contract. And so you could trade them on Pangolin or any of the other dexes that have launched up, or you can interact with all of these smart contracts exactly as you would for any normal token. And that it's really exciting because it doesn't really create any extra work for you, but we're unlocking this whole new class of assets that can be traded on the C chain and traded via smart contracts. And it's just really cool and really exciting.
So to compare then, how would you use an Avalanche native token on the C chain right now? Is it possible at all?
It is possible in test, for small applications. There are some bugs that I think we're fixing. Aaron might be able to speak to it a little bit more clearly, but it's going to be much easier, and you have to interact with them natively. But now we're able to wrap them into this ERC20 interface, which I should say we're rebranding this slightly. We're calling them ARC20s, which is the A for Avalanche. It doesn't really stand for anything anymore. But these ARC20 interfaces they'll make it actually usable in the first place, but it'll be really easy because it can just be swapped just like any other token.
Awesome. So again, seems like ease of use is really key here, especially as right now, maybe even I'm not a dev by nature or training, so would be much easier for me to do cross-chain transfers within the platform. So that's awesome.
Real quick, I wanted to weigh in. Plus, I think there are some other potential exciting opportunities here in the future. So, for example, I know right now there is a bridge being created to bridge Bitcoin Cash SLP tokens. That's the name of the token protocol on Bitcoin Cash, Simple Ledger Protocol. There is currently a bridge being created to bridge SLP tokens to our X-chain. So in the same way today we have our Avalanche Ethereum bridge, and you can bring over your ERC20 or ERC721 assets from Ethereum into our Avalanche C-chain. In the future, you'll be able to bring over SLP tokens from Bitcoin Cash to our X-chain. Then you'll be able to swap them to the C chain and wrap them as ARC20s and use them, for example, in a smart contract or Pangolin. So you can imagine Spice is a very popular token on BCH. You can imagine bringing over Spice token from BCH and using it on Pangolin, for example. So I think once we can get the X-chain, because today all of the exchanges have interfaces with the X-chain. That's what we've been pushing them to do. So,
hey Gabriel, I think you might be breaking up a little bit.
I think being able to tennies is going to be okay. Thank you. Sorry, my signal is poor. Thank you. Yeah, the high level is that we can potentially bring over assets from other chains through our X chain.
Awesome. So that yeah, then to kind of summarize Gabriel's point, seems like not only limited to just the ERC20s and that compatibility there, but potentially any other type of blockchain that wants to connect to Avalanche through perhaps a trustless bridge or some sort of bridge. Cool. Let's see. So I guess we did kind of touch on that a little bit with Avalanche native tokens on the C chain, but is there anything else that we haven't covered there? Perhaps maybe Aaron or Connor on that topic header.
Yeah. One thing that I think is really interesting about this is that basically the idea that we had was that we want these Avalanche native tokens to be treated as first-class citizens once they're on the C chain. So the really cool thing about Ethereum is that what we realized over the past years is that one of the best use cases for blockchains is to create these assets and to create lots of different standards for them. And so there's been huge success for the ERC20 standard, and other standards have added additional features and created these really powerful applications, and really powerful applications can be built on top of those. But at the very base layer, these things are not actually kind of first class objects within the Ethereum universe. They're actually just kind of smart contracts that are implemented as opposed to things that are owned by the person holding the private key. So the cool thing I think about these Avalanche native tokens once they're transferred to the C chain is that they are in fact these first class citizens. And what that basically means from an interface perspective is that they're treated the exact same way that ETH is treated on Ethereum or Epochs is treated on the C chain, which basically means that you can issue a call. It's the transfer and call kind of a opcode that you can basically do with one of the new pre-compiled contracts that we're adding, Apricot, which basically allows you to transfer one of these Avalanche native tokens and atomically at the same time also invoke another smart contract, which is similar to how the call opcode works in Ethereum. And additionally, there's a new similar to an opcode, a pre-compiled contract to get the balance of these. And so once you have those, you can actually interact with these outside of the context of the ERC20 standard, which is in our notion an ARC20 standard when these are these wrapped tokens. And so what I'm really looking forward to is just seeing what are the types of applications that we can build on top of this that are unique and separate from what's built elsewhere, because these things don't actually necessarily need that standard. That's just what most applications have been built on top of to this day. And the cool thing is that because these are first class within the C chain, there's more that we can build on top of them, and they are a little bit less prone to bugs because it's not going to be developers creating new things. It's actually going to be kind of a first class citizen within the C chain. So that's a really exciting thing to see what will actually get built on top of this new interface for tokens that are genuinely native to the platform.
And Aaron, you just while you were explaining that, you were talking about some of the more advanced contract calls that could occur with kind of the first class classification. Do you have any additional thoughts as to what type of applications could be built with that? Are there any that currently exist in other platforms, or even as ideas, I guess is a better way to phrase it? Just curious if you have any thoughts around that.
Yeah, so I think it's the really cool thing about the EVM is that you can actually basically build whatever you want on top of it. So you can create this new ERC20 contract that has all of this additional functionality. But then the problem with that is if you've added some new functionality that says, like, for one example is transfer and call is, I think, the ERC 777 standard, which is actually one of the things that's natively on these Avalanche native tokens now. And so that's like a really cool thing, but there are all these ERC20s that don't actually implement that. And so there's this kind of break in the standard where you have to care about, is it implemented by this or that? And so you actually have to have like wrappers around that layer. And so what I think is going to be really cool is just the fact that we have it implemented at the very base layer, so we can have all of these features there just as native features really, and see what people want to build on top of that. It's not that these are things that can't be implemented in the EVM as part of smart contracts, as part of a larger standard, but the really cool thing is going to be that everything will just kind of be there to start with. So it's going to kind of lower the barrier to entry for creating a token, because it's going to be so easy to create it on the X chain, move it to the C chain, and then already you have this full implementation that has all the features that you could want.
And do you, I guess this is maybe me not totally understanding what comes into the first class categorization, but how do you determine what standards are implemented on the Avalanche native token itself, or is it just bundling everything in it?
Yeah, so this is something that one of the difficulties with if you have an ERC20 contract is being able to upgrade that contract and say, okay, now I want to be able to do, so for example, this transfer and call thing. So if you want to say, okay, now I want to be able to do this, you have to go through this very difficult process of upgrading that smart contract to allow this transfer and call, which is a little bit difficult. And sometimes the contracts aren't implemented in a way where upgrading them is going to be easy. So that's one of the difficulties with kind of upgrading from an ERC20 to a different standard that might have more features. But because these are actually first-class citizens within Avalanche, if the community decides that at some point there's this new feature that they want to add to all assets, then we don't need to go through that process of saying, okay, we need to upgrade all of these smart contracts that were built on top of that. But that can actually be a network upgrade that says, here's a new feature we want to add to this type of asset. And that can be added in a much more easy way. So it's going to make adding new features much easier. And then as to your question about what makes it a first-class citizen, this is kind of or first-class construct is this is kind of like a CS term, which basically just means that it can get or I think I'm bungling this. Steven, do you think you could help me out here?
Yeah. So essentially, the notion of it being a first-class citizen is that it lives inside of the user's account Merkle tree alongside ETH. So currently, an ERC20 just lives inside of the ERC20's smart contract, and then inside of that, there's a map of address to balances typically. But our notion of an ERC20 actually lives inside the user's individual account. So on the surface, it just seems like we're kind of moving data around, but as we continue to kind of build off of it, this is a little bit more of like a extensible approach, from what I can see. So I don't know if that's exactly what you're going for, Aaron, but
Yeah, pretty much. Thanks for the help there.
Yep.
Cool. And seems like then this opens up the doors for also the governance layer that you're kind of alluding to a little bit, where then people who are part of the Avalanche ecosystem then have a say, okay, maybe this type of standard or this functionality is in demand, and so we should put up a proposal to try and get that to be accepted by the platform itself. And then if not, then we don't need to address that until the demand is there.
Yep, absolutely.
Cool. That's awesome. And then I think one of the final points we have, at least in the main subtopics for the upcoming upgrade, would be the consensus layer. And Stephen and Aaron, I know you guys have more expertise on this topic. Want to see if you can give a quick overview of what's going on there, and then maybe any of the future implications as well.
Yeah, so we've been constantly working on improving the consensus layer from performance perspective and also a theoretical perspective. So one of the major improvements that has kind of been on our radar is this Frosty consensus. And so Frosty consensus essentially works to take the best of both worlds of a classical consensus protocol along with the Avalanche consensus protocol. So the nice part about classical consensus protocols is that they have extremely well defined liveness parameters, and so you can have very strong guarantees on liveness and things relating to that. So Avalanche is extremely good at scaling to very large numbers of nodes and being extremely safe. However, liveness is not as good as some of these other protocols. So we very intentionally trade safety trade liveness off for increased safety, just because we feel like that's a safer and more natural way to implement a blockchain. The last thing someone wants is to have money just being like stolen. Essentially, it's much better when the network gets attacked to halt.
Quick question, Stephen. Sorry to
Yeah.
interrupt,
No, go
but
for
could
it.
you maybe outline and give a quick overview as to what liveness means versus safety in the context of consensus?
Yeah, absolutely. Sorry, yeah, if you can tell, I'm a bit of a
No
nerd.
worries.
So, anyways, yeah. So in distributed systems, there's two key concepts, which are safety and liveness. So, safety essentially ensures that if a node makes a decision, then another node will not make a conflicting decision. So, if someone accepts transaction A, no one else is going to accept transaction B that rejects A. Essentially, a double spend. So the last thing anyone wants is a double spend to happen on the network. So that's where safety comes in. Liveness is essentially ensuring that if I issue a transaction, it will eventually get accepted. So that's the kind of dichotomy of safety and liveness. So you can trade these things off. So if, say, someone's attacking the network, you can be extremely safe. So that, well, I'm never going to make an incorrect decision. But in doing so, you might trade off liveness. So Frosty essentially lets us be a little bit more careful with our choices and potentially boosting up some liveness without sacrificing safety is the goal. So that's something that I've been working on a lot with Kevin, and so that's something that I'm especially interested on the consensus side and rolling that out. Epochs is also very heavy on the consensus side, but I think we already talked about those. So
Awesome. Thanks, Stephen. And yeah, thanks for the quick overview of the definitions. I think it's pretty useful for especially the non-technical folks to really get where we're all coming from when we make those decisions.
Yeah, for sure.
Cool. So generally speaking, want to make sure that, especially with all the guys on the panel here, that we're not missing anything when it comes to Apricot. So if there's anything else that we may have glossed over a little bit or something that you want to emphasize, we'll give a few minutes for that as well.
I have a few points that I wanted to circle back to. So the first one is regarding fees. Recently, we've been getting a lot of noise around, when are your fees going to be less? As Stephen mentioned, the first phase of Apricot, which is rolling out, is going to reduce fees. I wanted to kind of bounce the ball to Stephen and see if he could sort of cover this topic. So initially, we had hard-coded the fees to being 470 gig away. This is gas. And then in the new Apricot build, it reduces it to 225, I believe. And then ultimately, we would like it to be dynamic. And I wanted to bounce the ball to Stephen to sort of walk through that and then cover what exactly do we mean by dynamic? What do we see the fees looking like in the best case scenario?
Yeah. So the way I see us moving forward here is going to be kind of like an EIP 1559 for any of the super nerds out there that know what that is. Essentially, Ethereum has been looking into modifying their gas mechanism, which is going to be included inside the Berlin hard fork upcoming, unless someone corrects me. And essentially what that does is that modifies the gas price logic to be a little bit more stable and predictable, and includes burning some fees, which we already do. So the goal for the C chain is essentially to set some kind of goals for the type of utilization that we're seeing. So, if a node is over using its CPU, hopefully the gas price is going to increase, and if you're using too much storage correspondingly, and then if during periods of very low utilization, the gas prices will go down. So right now it's just kind of hard coded, and we're at kind of like the bound of, we wanted to be very safe so that people wouldn't just DOS the network. But during times of low utilization, that ends up hurting the ecosystem because people can't, use the network as it really can be used, right? So essentially, the goal is to make the fees react to the current network conditions. So that's the rough goal with dynamic fees, and the way that it's exactly implemented is going to be based roughly on the Ethereum proposal, probably with some of our changes because of how we have asynchronous block issuance and things like that. So yeah.
And how about the X chain? I know, for example, on Bitcoin Cash, they do 1 Satoshi per byte, and then a transaction is maybe around 300 bytes, so it's 300 Satoshis. I think you and I had talked in the past transaction size plus number of signatures. So how about non-linear chains? How about DAG chains? Do we have a plan there?
Yeah, so what I've mainly been talking about was the upcoming gas rework on the C chain, but on the X chain and the P chain, we'll have similar mechanisms. So on the X chain and the P chain right now, actually transactions are fixed price. So essentially on the X chain, I think it's 1 milliAva to transfer something, and it doesn't really make sense that it's a hard-coded thing. I think we just kind of did that out of like time pressures. So there's certainly better ways to calculate a fee cost related to a transaction that's not as like DOSable and allows the price to again be lower for people that are just doing normal operations. So in addition to having a more expressive kind of cost function that takes in a transaction and determines some cost, we're also planning on implementing a similar type of when the network is stagnant or not performing at capacity, then you can lower the fees, and that's unlocked by epochs for the X chain. On the P chain, that's already possible because it's linearized with a notion of time. But on the X chain, epochs will enable us to vary the fees as the utilization changes as well. So yeah, good. It's a great thing to bring up. Thanks.
Got it. I have a couple other points. Should I just roll through them, Jay, or would you like to talk?
Let's do it. Go ahead.
Okay, awesome. So something I'm still unclear on. We have this ILOs coming up, and I know Jay can speak to that at a high level, but I wanted to ask the other engineers, are freezable assets a prerequisite for ILOs, or are those just something that are rolling out in concert?
So I can try to answer this one. So freezable assets aren't necessarily a strict prerequisite for ILOs. It kind of depends on the structure of the ILO itself, because that's just an initial litigation offering. For those of you guys who are listening that don't know, the idea is basically that we want to have similar to an initial public offering where a company raises money to go public, and people buy stock, and then that money goes into financing future operations. The idea here is that there's this huge class of litigation suits where people need to raise money in order to finance the lawsuit itself, and then the payout, whoever finances that can get a portion of the payout. And this is, I believe, a $10 billion asset class that at the moment is really only available to very wealthy investors, because this takes a large amount of money. These cases can take numerous years to develop and finalize. And then at the end, it ends up, only very wealthy investors can partake. So this is opening that up to crowdfunding, basically, that can take place on the Avalanche network. And so the idea is that people can pay into this ILO, very similar to an IPO or an ICO. And then whatever the result of that lawsuit is, that can pay out at some certain date. And so the reason that I think our first instance of the ILO, which was launched in partnership with a law firm that wanted to do this on the Avalanche network, was that they, in their particular case, they needed to actually be able to freeze these tokens at a certain point and then just pay out all of the holders of those tokens in some actual value that's either on-chain or off-chain. Once that happens, they don't want those tokens to be moved around anymore for basically regulatory reasons. And so ILOs is kind of one application of freezable assets, where for their particular use case, they needed to do it in this in order to comply with the regulations. They needed the ability to freeze that asset, and that opens the doors to regulatory compliance in a lot of other areas too. And so I think in the very first use case, it is a prerequisite based on what they needed in order to comply with regulations. But it's not actually necessarily a prerequisite if they didn't need to freeze those assets afterwards. So it would kind of be dependent on potential changes to regulations, where that ILO would be launched, etc. Does that answer the question?
Yeah, definitely. Thank you very much. I appreciate it. Okay, I have one last point, and then I'll pass the mic back to Jay. This isn't necessarily related to Apricot, but it's something I get asked all the time, and this is the perfect group to answer it. So, as I mentioned, our X chain has the notion of feature extensions, and that allows us to continue to add functionality to the X chain, or you can launch your own instance of the X chain, the Avalanche virtual machine on a subnet today, and you could potentially plug in your own feature extensions. So one feature extension we have talked about, and I believe even some work has been done, but of course I'll pass this back to Stephen or Aaron to answer, is post-quantum cryptography. That could be one feature extension. And then other ones we talked about are Schnorr signatures and BLS SIGs. So I wanted to kind of bounce the ball to Stephen or Aaron or Connor and say, if you were to brainstorm, what are some potential feature extensions that you see that could ultimately be added to the AVM in the future? And that's my last question. Thank you, Jay.
So yeah, to quickly comment on the quantum security or quantum safe signatures, we have actually implemented a feature extension that performs the quantum safe calculations, and essentially we just haven't. I think we ended up stopping work on that because what's the name of it? Anyways, they were essentially continuing to do a competition to improve and standardize the quantum safe signature scheme. So essentially we wanted to kind of wait and not jump the gun on implementing kind of a half-baked quantum safe signatures thing. Yeah, with other signature types, it's actually incredibly easy to implement new feature extensions like that. So yeah, I think that that's certainly something that we're interested in doing, is focusing on, especially with something like BLS and things like that can aggregate signatures, be super powerful while still having a relatively small size. Very interested in that.
Cool. Thank you. Appreciate it.
Awesome. Thanks, guys. So I think we have about 10 minutes left. Want to make sure if there aren't any questions in the audience that we make sure that we can address them. It can either pertain to Apricot itself, as we're very much in that topic, but also anything that's technical in nature, I think is good for this group as well. So happy to take any. Hey, we'll do it one by one, but I'll start adding some people. Hey, how's it going?
Hello. Hi, can you guys hear me?
Yes.
Hi, thanks for getting me up here. And this is my first time speaking in Clubhouse. I was wondering about the C chain, and specifically about the transactions per second that it can currently do, and if you guys are thinking about maybe considering optimistic rollups and other things. Like, I know that the chain is very has a high throughput, but if you give high throughput to users, they will fill it up and clog it up either way. We're lucky that we're in the beginning of our journey, but in half year's time, whatever transaction throughput you give the users, it's a possibility to do more arbitrages, do more stuff on the chain, and it will be used up, is my concern.
Okay, you want to take this one, Aaron?
Sure. Yeah, absolutely. Yeah, so you're completely right. We have very high throughput on the C chain, and users are obviously going to be motivated to use that throughput, especially with the low transaction fees especially as more stuff is starting to get deployed to the C chain. There are more and more DEXs, so that's driving more and more opportunities for arbitrage and different cool and interesting things like that. And yeah, optimistic rollups and all of the different optimizations, these layer twos that are being applied on top of Ethereum, they're all completely applicable onto the Avalanche C chain. And so, yeah, those are all absolutely things that'll be really cool to look into. I wish Tyler Smith were here. He's one of the engineers on our team who is just an absolute genius on this stuff. He's like an encyclopedia and seems to know everything about it. So he would be definitely the best person to ask about this on our team, I think. But yeah, all of those things are completely applicable to the C chain, so we can absolutely roll them out in order to continue to scale throughput. But yeah, obviously, if you have the base layer has much higher throughput, then that makes the layer twos even more scalable as well. Yeah.
Thanks. But in terms of just giving a rough estimate on like how many transactions, I know that Hedera, for example, talks about that they can do with their EVM implementation on top of a DAG, they can do 20 transactions per second on their EVM.
Yep.
So a quick comment on it. So I know that we have benchmarked in the past up to 200 transactions per second. That being
But those
said,
were just token transfers, weren't they?
Well, so to clarify, a transaction in Ethereum is totally, amorphous. You can implement something that's extremely fast, like a token transfer, as you say, or, something that takes, an entire block. And so, you have to be very, specific, I guess, on like how much gas is used on a per transaction basis. So if you want to get super technical, I guess you would say how much gas per second can you execute, and to that I would have no idea. I'd have to actually run some benchmarks. That being said, certainly as the state blows up, it ends up being more and more database read heavy, and so a lot of the state optimization and state improvements end up being extremely critical towards that. So so that's a benchmark that we have run in the past, but how applicable it would be, if we got up to something like Ethereum's, state size. I know we had thrown this number out, and a lot of the Ethereum people were like, oh, but you guys weren't running it on Ethereum mainnet and state, and they're right, they had valid points. So I think to give an accurate answer to this, we would have to set up an extremely sterile environment, to do comparisons. So
I see. Thanks a lot. Thanks.
Yeah. Thank you.
Awesome. Thanks for that question. Let's see. I'm gonna try and add more people here. Hey, we'll go one by one. Hey, Nate, you wanna go first?
Yeah, cool. Just hoping to get an update on the governance proposal for the staking and delegating, and the reduction of the amount of AVAX required for staking and validating as part of Apricot releases.
Want me to answer this?
Thanks, Steven.
Yeah. So we were pretty torn on whether or not we should reduce them, in essentially this update, or whether we should just push for a more general governance on the P chain. And I think the route that we kind of wanted to take was to just implement governance as quickly as possible for it. So certainly, at the levels we're at right now, the minimum staking amount is much too high, and so I think that for me personally, just speaking personally, I would much prefer to have a very low minimum validator stake amount, and essentially just move away from delegation entirely. Just me personally, and then have a system set up more for that. But I think right now we're essentially trying to put that in with just governance on the P chain. So that's kind of the current place we're at. I hope I answered your question. Maybe.
Wait and see, huh?
Yeah, exactly. Yeah, it seems like the timeline maybe isn't so clear externally facing, but of course we'll let everybody know once that becomes a little bit clearer.
Yeah, look, I mean, when you look at things like Overscan, you can quite clearly see that there's obviously a big skew towards first world countries having the delegation and validation, and quite prominently, I guess, it'd be great to see more sort of and more open to sort of developing nations. But look, that'll be, I'm sure it'll come later on.
Yep, that's a good point too, and it makes obvious sense as to why that's the case now, and hopefully we'll be able to mitigate that more towards the lower cost regions or the people that are looking for lower cost alternatives. Good point. Thanks, Nate. Mehmet, if you want to go next for the question.
Hi guys. Thank you very much for giving me this opportunity. I would like to ask, as you all know, as of today, there are nearly 7 or 8 DEXs on Avalanche mainnet, and I would like to know which of these DEXs are being supported by the Ava Labs team.
So I can answer this. So Avalanche is a platform. We allow anyone who has AVAX to transact on the platform and to launch their own smart contracts. So we in particular have no voice over who launches on our C chain or on any of our other chains. So from that perspective, we don't gatekeep who can launch. But as far as these DEXs, who have we actually supported? We have worked on Pangolin, and that is the only app that we have worked on ourselves. We've provided some support to other people through debugging channels and things like that. But I'm not sure if we've co-marketed with any other exchange or anything like that.
Okay, thanks very much.
Yeah, I guess from the marketing side would definitely echo the unbiased approach. At the end of the day, right now it seems a little bit manageable when it comes to the inbound requests, but soon probably as the platform continues to grow in use and also people building on it, then there's just going to be far too many to personally handle, at least not from the Ava Labs side. So the main way we're approaching co-marketing is not necessarily an endorsement, but just a way to provide projects with a platform to be able to speak to everybody about what they're working on and how you guys in the audience can leverage their technology to do certain things. And of course, we are doing as much due diligence as possible. But I think one of the things, again, that we try and push is do your own research, ask the questions. We'll try and give as much objective information as possible. If we don't happen to know anything about a certain project, then we'll usually say that instead of misleading with certain opinions and whatnot. So yeah, that's a good question. Yeah, next question. I think Gom maybe is how you pronounce your name. And you might be on mute. Okay, well, in the meantime, we'll bring up others as well. There's 2 more. We'll see if they accept the invite. Hey, Erwin.
Hi, guys. Can you hear me?
Yes,
I think so.
Can hear you. Yep.
Cool. Thanks for the opportunity. I got a lot of questions actually, but I won't go into all of them. The most important one that I'm thinking about here is in regards to 2 things. First is, do you guys have plans or support for, let's say, developers that want to write a different client for the Avalanche other than the Avalanche Go? And the second question is related to the resolution of these epochs, because if I understood what you guys were talking about right now, it was going to be about 6 hours or so. I assume that this means that, for example, if you want to free an asset and unfreeze later, you can only do in epochs steps. So is it going to be that the resolution is adaptable via governance, for example? That would be the second question.
Honestly, I hadn't thought about that. It is possible to make that governable, and so maybe it should be, but yeah.
Okay, so it's possible. That's good.
Sorry, what was
Steven,
it?
you can probably answer this one. Other clients other than Avalanche Go?
Oh yeah, I would love that. So we've actually internally worked on a Python client that so it isn't kind of ready to be rolled out. And I don't know exactly what the plans are for that at this point, but yeah, we would love that. Definitely, we don't like running a network with a kind of homogeneous, like if there's a bug in Avalanche Go, then stuff breaks, and we saw that happen with the network slowdown like a month and a half ago or something, or maybe two. Anyways, so those kinds of things get fleshed out much faster when you have multiple clients, and so that's that's totally something that we're very much interested in and have in the past kind of worked towards. So
I'm asking this because there's this thing about Avalanche X grants, and I'm wondering if there is incentives in that direction. Thank you for answering.
Yeah.
Go ahead, Steven. Sorry.
Yeah, no, I was just saying a comment on that is that obviously implementing a client is a lot of work. Avalanche goes very long time in the making, so that would probably be a massive grant. But yeah, no, we're definitely very interested in expanding out in that area. Go ahead, Gabriel.
Yeah, I just wanted to say to echo what Steven was saying, there has been a lot of work on a Python client. It's actually very close to being across the finish line. It just needs a little bit of love to get across the finish line. And I know of an Avalanche Rust client which has been started. The repo is not on our team, but externally. The repo isn't open source yet, but I know there's work there. Just as Steven said, whenever you have a homogeneous network, it's brittle. And similar to web browsers, if there's multiple browsers, multiple clients, you can suss out bugs. So yeah, I echo what Steven says. We would love to see a diverse and heterogeneous network of clients. And to answer your specific question, as far as I know, there is not a formal Avalanche X grant, but of course you can submit a proposal.
Cool, thank you.
Awesome, thanks everyone. All right, so we're just up at the hour, and I know some people join in partially way through. No worries, we have this all recorded, so we'll have this uploaded on the Avalanche YouTube, and that'll be up either later tonight or tomorrow, and that's where you could view the recording. But for now, this is great. If anyone has any feedback about what topics you would like us to cover, please DM any of us, and we'll make sure to get that rolling. And then I think in the short term, just to give people a preview as to what we're focused on, we're very much trying to talk about all the things that we're building at Ava Labs, and also subsequently then all the Avalanche improvements and whatnot. But I think in the very midterm, in terms of time horizons, probably in the next month or so, we'll start bringing in some of our partners and also applications that have start building upon us, because I think as much as a lot of the Avalanche specific things are very interesting, there's of course a lot of interest on the DApp side and then also everything else in between. But for now, appreciate it you guys joining, and we'll catch